Hello. Yes, we welcome you back to our channel, Natural Sciences Grade 8 and 9. That's the name of the channel. Yes, today we are looking at this question. It says that consider the circuits below, consisting of similar cells, bulbs, ammeters, and connecting wires. So these are the circuits we are having. Okay? And the question comes, it says that state the arrangement of cells in circuits B and C. They say right series or parallel. Okay? Yes. These cells, here we have one cell, we have eliminated it, but here we have two cells. And here we have three cells arranged. Yeah, then the question comes, it says, state the arrangement of cells in circuits B and C. Okay? They say right series or parallel. Okay, what arrangement are these? Okay, this is what we're having. This is B and C, and we have these cells arranged as shown above. The answer is a parallel. Okay? Yes. Then the next question comes. It says that give a reason for your answer above. So we chose parallel. And what's the reason for our choice of parallel? Okay, the reason is that different paths are provided for the flow of current through the cells. The current reaches here and it divides. Some passes that into that, some passes here. The same applies here. Yes, there is this alternative path. Some current will pass here and another current will pass through this one. So in a situation where different paths are provided for the flow of current, that arrangement is called parallel. Yeah, that is it. Yeah, when we come to this question, it says that the potential difference or voltage of each cell is 1.5. Okay. What is the voltmeter reading on each of the circuit above? Okay. We have one cell here. We have two cells here. We have three cells here. Yes. And we have the voltmeter. So the question is very simple. What is the voltmeter reading on each of the circuit above? Let's look at A. A, it is 1.5 volts. Surprisingly, for B, it is also 1.5 volts. Yes, in the same spirit, even for C, the voltmeter reading is 1.5 volts. Yes. This what happens when the cells are arranged in parallel. Yeah, then comes this question. It says that compare the ammeter reading of each of the pair of circuits below and give an explanation for your answer. Okay, the first pair is A and B, this one and this one. Yes, they want us to compare the ammeter reading, this one. Okay, How are they related? The answer is they are the same. Yeah, shockingly, it's the truth. They are the same. Yeah, explanation. So we said they are the same. What is the explanation for these two ammeter reading being the same? The answer is that they have the same potential difference. Remember, we said that if this cell is 1.5, the reading here is going to be 1.5 volts. And we said it's the same here, even though these are 2, this one is also going to be 1.5 volts. That's what happens when the 2 cells are connected in parallel. So if this is 1.5 and this is 1.5, the ammeter reading is also going to be the same if the bulbs are the same. So what's the explanation here? They are the same because the potential difference across is the same. Yeah, that is that. The potential difference is the same, so is the current. Yeah, then we come to this one. It says compare the ammeter reading of each of the pair of circuits below and give an explanation for your answer. So we are comparing B and C. And what are you comparing? Ammeter reading. How do they relate to each other? The answer is they are the same. Yes, very surprising. Yes, they are the same. Yeah, explanation. Yeah, what is the explanation of this ammeter reading being equal to this? The reason is that, yeah, in both circuits, the potential difference is the same. Yeah, we say this is 1.5 on our assumption that each of the cell is 1.5. And so is this one, despite the fact that these are 2 cells and these are 3 cells. Okay, the issue is that if it doesn't matter how many cells, provided they are of the same kind and they are connected in parallel, the potential difference will be the same as that of one cell. So what are we going to put here? The potential difference across is the same. Yeah, so that is that. Let me get something which used to puzzle me. If one cell gives 1.5, and 2 cells give 1.5, and 3 cells give 1.5, I used to ask a question to myself that, then what would be the reason for me having many cells in parallel? The reason lies in the fact that the more cells you have in parallel, the longer that battery will sustain the current. So this one will take long to be drained compared to this one, compared to this one. So that's the explanation as to why we put so many cells in parallel, despite the fact that they give the same potential difference. And with that, I would like to thank you for your time. The channel is Natural Sciences Grade 8 and 9. That's the name of the channel. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.